Okay, now let's work through station C, our last station. So just like station A and B, we need to estimate the arrival of the P wave and the S waves and then determine the lag time. So I'm going to pick a color. And so here we have noise, and then we're looking for a jump in the amplitude, and I'd say it happens about right there. So I follow that down to my timeline, and then I'm going to estimate what time that occurred. So I'm going to say, since each one of these is worth 5 seconds, it was 8 o'clock, 37 minutes, and about 34 seconds. So 8, 37, 34. Okay, I'm going to change my color. Okay, so now I'm looking for my next big change in amplitude. So we're going along, still S waves, and it looks like it happens about right here. So I follow that down to the line. I'm going to estimate what time that occurred. So now I've changed minutes. I'm not at 8:37 anymore. I'm at 8:38. So I'm going to estimate about 3 seconds after 8:38 is when the secondary wave arrived. Okay, so determining the lag time here throws a couple people off because we're used to doing subtraction in terms of tens and hundreds. So you got to remember here when you're doing this time that it's on seconds, and so it's 60 seconds. And so the first thing I would do is determine how much time went from 37 minutes, 34 seconds to make it 38 seconds. And so that would be 26 seconds. And then we have 3 more. A lot of people subtract this and they'll put 31 or, other crazy stuff. You got to remember that when we're dealing with time, that's on the base of 60. Okay? So we got 26 seconds to make it 38 plus 3 seconds, which makes our lag time 29 seconds. Okay? So I'm going to take that information to the graph. So 29 seconds is going to be half between here. So I follow that over. Whoops, I didn't draw a straight line. Let's change this to be a straight line. There we go. I follow this down. So it looks like it's almost smack dab on the line. And so we got 200, 210, 220. So I'm going to estimate the distance away from station C is 220 kilometers. I'm going to take that information. Now I need to draw my circle around station C to estimate the distance away from station C. So I need to make my circle have the radius of 220 kilometers. So if I start here at 0, here's 200. So I need to be on the second line right here. So let's see. Let's make it red. So I'm just going to randomly draw, well, not that. I'm going to pick the circle, and then I'm going to randomly draw a circle over here, choose my selection tool, and move it over and see how close I got. So again, if you line this up with 0 and then try to put the 0 be the center point of your circle. And I'm not even close. I'm at 160 some odd. So I need to make my circle bigger. Recenter. So now I'm at about 205. There we go, about 220. So now if all things worked out perfectly, when I center this on station C, it should somewhere come close to being in 1 point. See, I tried to cheat there. Okay, so it looks like I might be just a little off. And so what I can do is I can go back and re-estimate. But now we have the intersection of the 3 circles. So in this area right here is where the possibility is for the epicenter. Now what I should probably do is go back and re-estimate the size of my circles, or look and see if it looks like maybe the B isn't quite centered in my circle. So if I try to center that a little better. Nope, that didn't help any. So I probably need to go back and re-estimate the size of my circle over here on the key. But that's pretty close. Somewhere in this area right here is where the epicenter of the earthquake occurred.